In this video, we'll design and model an A-frame tiny house from start to finish. We'll go through the entire process step by step, from the foundation all the way to the exterior details. If you're interested in architecture and enjoy designing small, efficient spaces, this video is for you. Hello everyone, I'm Hossein and welcome to my YouTube channel. Today we're going to model a unique A-frame tiny house together. With its distinctive A shape, this design has become one of the most popular and appealing options for small homes. But what exactly makes this design so popular? A-frame tiny houses don't just stand out because of their unique and eye-catching appearance. They also offer several practical advantages that make them suitable for different weather conditions. The steep sloped roof helps the house handle snow and rain more effectively, while also giving the building its distinctive character. Inside, the space is efficiently optimized, with every inch used to its full potential. All of these qualities make A-frame homes both functional and visually appealing. Another important point is that A-frame tiny houses are designed to fit easily into compact sites and a wide range of natural environments. This makes them an ideal choice for anyone looking for a simple yet modern lifestyle. So if you're thinking about owning a small home with a unique and highly functional design, don't miss this video. To get started, I've prepared an AutoCAD file of the section of this tiny house, which you can download from the description link. Now that we've explored the features and appeal of this design, let's dive into the modeling and construction of this creative tiny house. Now that we've prepared the initial setup, the first step is to change the units to centimeters. This ensures that all the dimensions and measurements are accurate and fit the project. To do this, we start by changing the default units to centimeters. Then, we import the AutoCAD file we previously prepared into Rhino. Once we've imported the file, we create a new layer called AutoCAD and place the imported layers as sublayers under this main layer. With the files ready, I select the drawing, use the gumball tool to rotate it to a vertical position, and move it slightly to center it on the page. After adjusting its position, I lock it so it won't change. This makes it easy to refer to it whenever needed. Next, I create a new layer called Swiss Cabin. From now on, all modeling layers will be placed as sublayers within this main layer to keep things organized. To begin modeling the foundation, we create the first sublayer called Base. Now, we move to the front view, where we have the locked drawing. Using the polyline tool, I draw a closed line that marks the foundation section. We then extrude this line by 60 centimeters. After building the main foundation, we move on to the blinding concrete. To model the blinding concrete beneath the foundation, we extend 35 centimeters beyond the edge of the foundation on each side using the gumball tool, then extrude it by its width, 130 centimeters. We do all of this carefully to ensure the dimensions are accurate. Now, we'll move on to modeling the column base plate. To do this, I draw a rectangle and use the set XYZ coordinate command to place it exactly at the center of the foundation axis. After adjusting its position, I extrude the plate and activate the both sides option to give it volume. This ensures the plate is perfectly centered, giving us more control over the model. We repeat the same process for the column. First, we draw a rectangle and position it at the center of the plate we previously created. Then, we offset it by 1 centimeter and extrude the column to the height we set in the locked section. We follow these steps exactly as you see on the screen. So far, we've modeled the foundation, the blinding concrete beneath it, the column, and the column base plate. As you can see, this tiny house is completely symmetrical, and the axis of symmetry is marked on the drawing. To speed up the process, we can use the mirror command and the symmetry axis to easily copy the foundation and column on the opposite side. Just like you see here, we copy these parts to make the work faster and ensure the accuracy of the model. Now that we've completed the initial steps, let's move on to the main horizontal beam. To do this, we first draw a rectangular section of the beam using the same method we discussed earlier, then position it along the axis of the columns. After adjusting the position, we use the extrude command and activate the both sides option to give the beam a thickness of 5 centimeters, ensuring that the center of the beam aligns with the center of the column. This ensures that the horizontal beam is correctly and accurately placed on the columns. At this stage, we've completed one full module of our structure, which includes the foundation, blinding concrete, column, and horizontal beam. Now we select all these elements and copy them 7 times at a distance of 150 centimeters along the length of the project. This is how the main structure starts to take shape, placed systematically and precisely in the design space. Next, we move on to the horizontal beams that run along the length of the structure and at the floor level. For this, we draw a rectangular section of the beams from the section we previously locked, and using the set XYZ coordinate command, we position the beams exactly where they should be, right next to the main horizontal beam. Then, we extrude them to the full length of the structure so that all the longitudinal beams are in place. As you can see, we perform these steps with precision. To create the mirrored beams on the opposite side, we use the mirror command and place the mirrored horizontal beams in their correct positions. We repeat this process for all the similar beams on the floor to ensure that every horizontal beam is placed correctly and there's no interference between any of the parts. To make the final model cleaner and more precise, and to avoid any geometric clashes between the beams, we use the Boolean split command. This removes the parts where the main transverse beams intersect with the beams we previously created. After this step, we select and delete the excess pieces that are separated. This process ensures that the intersection of the beams is completely clean and accurate, and the final model takes shape in an organized and precise way. Finally, we move on to the flooring. Just like the previous steps, we start by drawing a rectangle from the section, position it correctly, and then extrude it along the full length of the structure to form the final floor of this part of the tiny house. As you can see, with each step, the different components of the structure are being built with precision and a clear sense of order. Next, we move on to the A-shaped beams of the structure to fully shape the main form of our tiny house. The first step is to draw the beam section using the polyline tool from the locked base. We create this as a closed line to define the beam section accurately. After drawing the section, just like always, we use the set XYZ coordinate command to position the beams precisely, and then we extrude them by 10 centimeters to give them volume. At this stage, in addition to the main beams, we also have 2 diagonal beams, which are designed to better connect the beams to the columns beneath. We model these diagonal beams with the same precise method as the main beams to ensure everything connects properly. Once all the beams are created, it's time to copy them. We select all the beams and, using the copy command, we place them at a fixed point corresponding to each foundation, ensuring that the beams are positioned correctly and the work proceeds smoothly. Next, we create a new layer called ground. Using the section we have, we draw a surface to represent the ground, marking the ground level and giving the model a more natural appearance. This tiny house also has a small mezzanine, which is designed as a sleeping area. To create this mezzanine, we draw and model the horizontal beams and place them along the axes we've set for the mezzanine. Just like I'm doing now, we place the beams in the correct positions. To complete the modelling, we also draw the floor of the mezzanine and the ceiling of the lower floor, extruding them to the appropriate size to finish the structure and complete the modelling. Next, we copy one of the main longitudinal beams we created at the bottom to the highest part of the A-frame structure to improve the connection between the frames. This helps strengthen the overall structure of the tiny house, and we can say that the main skeleton of the building is now complete. Now at this point, there's an important thing to consider: layer organization in the model. To tidy up the model and create more structure, I create a new layer called Structure and select all the beams and columns, then use the Change Object Layer command to move them to this layer. This ensures that all structural components are placed in one specific layer, making it easier to work with the model. To separate different sections, I create another layer called Floor and move all the floor panels into this layer. Additionally, I create a new layer called Ceiling and assign the ceiling of the mezzanine to this layer. This makes the model more organized and neat. Finally, I enlarge the ground plane we drew earlier and improve the layer color organization to make the model look more visually appealing and cleaner. Of course, this section is fully customizable, and you can change the colors and sizes based on your personal preferences. If you enjoyed this video and found it useful, please support the channel by liking and subscribing. Your support helps us create better content and grow the channel. If you think this video could help your friends or colleagues, don't hesitate to share it with them. A big thanks to everyone supporting us through Super Tanks. Your support really motivates us to keep making high quality, valuable, educational content. Now, let's move on to modeling the exterior facade of the tiny house. The first step is to create a new layer called Facade and activate it, so all the facade modeling steps are done in a neat and organized way within this layer. To start, we use the Polyline tool to draw a line on the A-shape edges. Then, using the Set XYZ coordinate command, we flatten it so that it's positioned exactly where it needs to be. As you can see, this line is carefully placed in its correct position on the model. Now, to complete the profile, we offset this line by 1 centimeter and set the cap option to flat to create a closed and complete line. This ensures that all the edges are defined correctly and the profile is ready. To cover both sides of the facade properly, we mirror this profile along the center axis to create sheets for both sides of the facade. Next, we extrude these profiles to the center of the next beam. As you can see, the profiles align perfectly with the beams, ensuring there are no issues with dimension coordination. To make the final facade look more realistic, we leave a 2mm gap between each profile and the adjacent profile. These gaps help add more detailed precision to the external facade model, making the space look more appealing and lifelike. Using the same method, we copy the profiles to cover the entire facade and complete the model. If the sheets are slightly larger or smaller than the beam spans, we use the scale 1D command to fit them perfectly so the sheet dimensions align properly with the structure. This ensures no discrepancies in sizes and that all parts fit together perfectly. Finally, just like what you see in the image, we repeat this process for all sections of the exterior facade to create a complete and realistic final facade model. Next, we move on to modelling the interior wall. The first step is to select the ceiling layer and, as shown in the image, draw a polyline. To ensure the interior wall is slightly away from the beams and gives the model a cleaner look, we offset it by the desired distance using the offset command. After adjusting the distance, I extrude this line to the full length of the structure, so the interior wall is fully formed and integrated into the interior space. Now, we move on to the exterior cladding sheets that need to be placed on the structure. This step is identical to the previous one, so I won't repeat the details. You can follow the same method to model the sheets and complete the exterior facade. Next, it's time to model the windows and the front door. To do this, I create a new layer called Window and begin modelling the windows. First, I draw a panel that fits precisely within the triangular frame. I do this with the polyline tool and then use the set XYZ coordinate command to flatten it. Once the panel is in the correct position, I move it inward by 60 centimeters and use the planar curve command to convert the panel into a 2D surface, which we can use as the base for the windows. For better visibility, I isolate the panel so we can see it more clearly and track the progress. Now, following the image, I use the polyline, trim, and other 2D commands to design the window frame. In this section, I also design the front door and place all the related parts properly within the frame. After designing the window frame, I extrude it by 5 centimeters to give it the appropriate thickness. Then, I transfer the panel, which will serve as the window glass, to a new layer called Glass for easy access later. I repeat these steps for the rear side of the structure, just as I described. I duplicate all the window and frame design steps as shown in the image to complete the entire facade properly. For modelling the door, I first split the frame I drew earlier using the split command and separate the section for the door. After removing the door section, I design the door frame and extrude it to the proper thickness. Since I've already explained all these steps, I won't go into further detail and will move directly to the next stage. Finally, I design and shape the door to complete the front entrance. This video is part of the beginner series, so we won't delve into fine details. We designed the door with these simple details so it can be added to the model. However, you can also use pre-made objects for doors, which I mentioned in previous videos. In upcoming videos, I'll teach more complex details with additional intricacies, but for now, this is enough to cover the main steps of modelling both the interior and exterior facades. Now, we move inside the tiny house and focus on the interior details. The first step is to create a new layer so that all the modelling steps for this section are done within this layer. Then, we proceed with all the steps just as we did before. To avoid repeating explanations, I'll highlight only the essential points, and the rest of the steps will follow as shown in the image, so you can easily understand the process. There's nothing complicated or new here. Everything is similar to the methods we've already used, so we'll move through the steps quickly. We've completely modelled an A-shaped tiny house, also known as the Swiss design. As you can see, to give the model a more appealing and attractive look, I've added some materials to make it more visually interesting. If you have any questions about material application in Rhino or want to learn more about this topic, I have a separate video on the channel where I explain the full process of material application. I highly recommend checking it out if you haven't learned this part yet. I'll leave the link in the description for easy access. Now, for the tiny house entry, I'm going to create a simple step. To do this, I'll model the steps using a few basic boxes and placing them together. This step is just as simple as the previous ones and adds the finishing touch to the project. With this, the entryway is beautifully completed and the model is ready. In this video, we've modelled a complete A-shaped tiny house from start to finish. Using various tools and methods in Rhino, we've modelled the main structure, exterior facade, windows, doors, and even the interior details. Finally, we've completed the project and added materials to give it a more realistic appearance. I hope this tutorial has been helpful and you've been able to grasp the concepts well. If you have any questions or if anything is unclear, feel free to ask in the comments and I'll be happy to guide you. If you enjoyed this video, don't forget to like and subscribe to support the channel. This motivates me to create even better videos for you. Also, feel free to leave a comment with your thoughts and suggestions. Your feedback helps the channel grow, and it allows me to prepare even more exciting content for you. Thank you for joining me. I hope this video was helpful to you. In future videos, I'll be back with new tutorials and more interesting projects. Take care and stay successful.